Hi, this is King of Review. In this problem, we want to solve the system of linear equations by using Cramer's rule. So if we have two equations that are in the form ax plus by equals e and cx plus dy equals f, then we can use Cramer's rule to solve the system. That is, find x and y. Cramer's rule is a method that uses determinants to solve a system of linear equations. Cramer's rule states that we can find x by taking the determinant of the x matrix and dividing it by the determinant of the coefficient matrix. And likewise, we can find y by taking the determinant of the y matrix and dividing it by the determinant of the coefficient matrix. So let's set up our three matrices. The first is the coefficient matrix. So the entries in this matrix will be the coefficients of our x and y terms. So A, B, C, and D. The x matrix, this is going to start with E and F. And you notice E and F are the constants of the two linear equations. And then we have B and D. And then the y matrix, this is equal to A, C, E, and F. So now that we know the setup for these three matrices, let's insert our specific values. Looking at our system of equations, the coefficients are 5, 1, 3, and negative 2. So 5, 1, 3, and negative 2. The x matrix, we start with E and F, which are the constants. So negative 13 and 0. And then we have B and D, so 1 and negative 2. And then our y matrix, we have A and C, so 5 and 3. And then E and F, negative 13 and 0. So now we've set up our three matrices. Now we want to solve for x and y. Now looking at Cramer's rule for x and y here, we need to find the determinants of these matrices. So what is a determinant? Well, a determinant is a real number that's associated with a square matrix. So let's say we have a matrix that has entries A, B, C, and D. If we want to find the determinant, we're going to take the product of the entries in the main diagonal, so AD, and then subtract the product of the entries in the other diagonal, which is CB. So AD minus CB, this will give us the determinant. So let's find the determinant for our coefficient matrix. We'll start with the product of the main diagonal, so 5 times negative 2, and then we'll subtract the product of the entries in the other diagonal, 3 and 1. So we have 5 times negative 2 minus 3 times 1, and when you work this out, you get negative 13. Now for the determinant of the x matrix. We'll take the product of the main diagonal, so negative 13 times negative 2, and subtract the product of the entries in the other diagonal, so 0 and 1. And when we work this out, we get 26. And for the determinant of the y matrix, we'll take the product of the main diagonal, so 5 and 0, and then subtract the product of the entries in the other diagonal, 3 and negative 13. And when you work this out, this is equal to 39. So now let's solve for x, the determinant of the x matrix. We solved for that, that's 26, over the determinant of the coefficient matrix. That's right here. That's negative 13. So 26 divided by negative 13, that's negative 2. So x is equal to negative 2. And now for y. The determinant of the y matrix, that's 39, divided by the determinant of the coefficient matrix, that's negative 13. And when you work this out, you get negative 3. So y equals negative 3. So we've solved our system of equations. We've found the x and y value. Letter E is correct. Thanks for watching.